Thanks for making the High Pressure Podcast part of your day. I'm Jeff Beamish, air quality meteorologist at Sonoma Technology here in the San Francisco Bay Area. As always, joined by my air quality forecasting colleagues, Patrick Zahn and Steve Irwin. Let's take a look ahead now to winter 2022-2023. Not only the winter outlook, but how weather conditions may influence AQI levels in the Mahoning Valley. And for more on that, here's Steve.
Yeah, it's always an exciting time of year for me. I'm one of those people who loves snow and loves winter, and so it's fun to look down the road and see what might be coming, not only from a snow perspective, but also from an air quality perspective. So focusing on Youngstown-Warren here as we look at the winter ahead, something that we like to talk about in meteorology a lot when we're looking at long-range forecasting are teleconnections. Teleconnections is just a nice big meteorology word that means our weather is tied to things happening all around the planet. And some of those things that are happening that can have a big influence on our weather are the temperatures of the ocean. So that's one of the main teleconnections that we like to look at as we're looking out a few months to try and see what the weather is going to do. And so this is sea surface temperature anomalies. So red would be above normal sea surface temperatures and blue is below normal. And what we're seeing here is a continuation of the La Nina conditions that we have had for the last couple of years. And I'm saying that by looking here in the equatorial Eastern Pacific, we have water temperatures that are below normal. And just looking at, we have had the last two winters have been La Ninas, and in the historical records, which go back to 1950, this is only the third time on record where we've had three La Ninas in a row. The last two times, 1973 to 76 period, and then also from 98 to 2001. And so pretty unique and rare occurrence here to get three La Nina winters in a row. And another thing that jumped out looking at sort of the climate indices as we head toward the winter is the Pacific Decadal Oscillation. And that oscillation is also tied to ocean temperatures here in the Pacific. La Nina is part of that, but it's also characterized by this area of very warm sea surface temperatures in the interior North Pacific. And both of these teleconnections, La Nina and the Pacific Decadal Oscillation, work together to kind of force the same type of weather pattern over the United States. So that's something that we're going to focus on here as we look ahead. And also just to look at where we are with the Pacific Decadal Oscillation currently, we're at pretty historically low levels. We've come up a little bit from earlier in the month, but still running in this -2 to -3 region. And you can see that's only happened, a handful of times as we look back through this record, which goes back all the way to 1854. And so this would be this negative or cool phase of the Pacific Decadal Oscillation is supportive of La Nina continuing through this winter. If we look back to last winter, we also had similar conditions. We had a moderate La Nina, and we also had the negative Pacific Decadal Oscillation. And here's how things worked out last winter. We had above normal temperatures across the southeastern US and the Youngstown-Warren region. It was near normal with the above normal temperatures just off to the southeast. And then as we look at precipitation over here on the right, that was above normal precipitation across the Ohio Valley. And really that was one of the only spots that had above normal precipitation last winter. So as we look ahead, it's sometimes helpful to look back. We want to look back and see when the ocean conditions were similar, how did that affect weather over the US during the winter months? And so this is sort of a reconstruction of what happened all of those years. So this is a compilation of all the weak to moderate La Ninas, which is what we're expecting this winter, not a strong La Nina, but weak to moderate La Nina. And we can see for Youngstown-Warren, it's generally near normal to slightly above normal temperatures and near normal precipitation. And again, this is looking back to all the weak to moderate La Niñas since 1991. If we look at a similar time frame here, and we're just looking at the years where we had a pretty strong negative PDO heading into the fall months, this is what we had. So I can kind of go back and forth here so we can see the differences. So it's warmer across all of Ohio, but similarly near normal precipitation in Youngstown-Warren on these winters. Another thing we like to look at is trends. And so we can see all the La Nina winters, and then also look at if there are any trends in our winters, if they're warming up, if they're getting wetter, if they're cooling, how those things sort of add together to produce an overall forecast. And so here, looking at La Niñas plus the trend in winter temperatures, it also shows slightly warmer than normal temperatures for Youngstown-Warren. And then we're looking at pretty much near normal precipitation again in that region of Northeast Ohio. Beyond that, so we've been looking at the ocean and the teleconnections with La Nina and the other indices. They also have model forecasts that go way out into the future that take in many other things in the climate system. So, the Pacific Ocean is just one piece. There are many other pieces that obviously play into what sorts of weather patterns develop over the winter. And so this is the European model's outlook for December, January, and February. And again, pretty similar to what the other patterns were showing, with slightly above average temperatures across Ohio. This is different though, in that the model is indicating a chance of above normal precipitation that is similar to what we saw last winter in that region. However, looking at where La Nina is this season, it seems like we're in a stronger La Nina than where we were last year at this time. And also with that very negative Pacific decadal oscillation, I would think we would stay closer to those analog years from the past. But this is definitely something to keep in mind as we look ahead to the winter. And then one final model forecast for the same period is from a Canadian model, CanSIP's model, also showing slightly above normal temperatures here on the left. But this one is kind of out in the extreme as far as how much precipitation could occur. CanSIP's model has well above normal precipitation all across the Ohio Valley for the coming winter. And so taking all of that in, the people who do this on a regular basis each year are the folks at the Climate Prediction Center. And they take all of these things into account when they make their seasonal outlooks. And so as they bring all those sources together, this is what they've come up with as we look at the winter ahead. And there are a lot of things that we saw on those past maps where we have warmer than normal temperatures just southeast of Ohio. They have equal chances across Ohio for either above or below normal temperatures. And then you can see some of that model influence likely with the above normal precipitation forecasts. Looks like they're really focusing a little bit further northward into the Great Lakes, but some of that effect is reaching southward into the Mahoning Valley this coming winter. And so as we sort of think about putting all those pieces together, temperature wise, it looks like we're going to be near average to above average. That's what most of those maps were showing. Precipitation is the hardest one to pin down, of course. And again, as I was mentioning before, I think with La Nina as strong as it is at this point of the year, and then where the PDO also is sitting, I would think this would be maybe slightly above average, but probably more likely even near average precipitation, possibly, as we head into the winter. And so, thinking about all of these things, if we think about going back to what you, Jeff, had shared and what Patrick had shared about the different types of weather that brings higher pollution episodes for the Mahoning Valley, it would seem like, at first glance, this wouldn't be a worse than normal year because we're expecting warmer temperatures, which decreases the magnitude of those inversions. So we wouldn't have as many or as strong inversions during the winter. And then with near normal or even possibly above normal precipitation this winter, more weather systems would promote mixing and dispersion and possibly bring improved air quality this winter in Youngstown-Warren. So that's how things are looking at this point, and everything can change as we get closer. The oceans are a very stable signal. It takes them a long time to cool up and warm down. So I think, we should have a pretty good handle on what's coming. But certainly we'll be paying attention to this as we head closer to the winter months.
Thanks a lot, Steve. So one thing I wanted to mention was climate forecasts looking out several months into the future are notoriously difficult. Air quality forecasts that are based on those climate forecasts are even more difficult. So this is a real challenge, but this is giving us some key information that prepares us as we go into this next winter season. A lot of times people are wondering in general how air quality will be in the upcoming months. And as Steve mentioned, especially with the potential for increased precipitation, that might indicate more frequent storms and frontal passages. Those tend to increase mixing and dispersion. But one thing I wanted to mention really quick that might swing it the other way, if you have a temperature anomaly, as Steve mentioned, that could mean fewer strong inversions, but that might also indicate more frequent winds out of the south where the air mass is warmer. And sometimes when you have more frequent southerly winds, well, that's not a great direction for the Youngstown-Warren region because there are a lot of upwind sources of pollution. So it's kind of difficult to tease out what the actual implication will be for air quality, but we will be considering all of these factors as we look ahead.
And one thing that I'd like to point out, Patrick, is in regards to the precipitation outlook, because if we do see more frequent frontal passages, we see more rain and snow, that may also boost the odds of an increase in high humidity and also fog. Those are factors that can actually enhance particle production, thus driving AQI levels up. So, a little bit of a balancing act, right? You might have several frontal passages during the winter months that are increasing mixing, but if we have light winds and a lot of moisture around and fog, possibly snow melt, that can also swing air quality levels toward the moderate category.
And I thought that we should increase the stakes here just a little bit since we are talking about these competing factors. I think we should make a burrito bet about what the air quality is going to be for this next season. So we're looking at the PM season, which we define for Youngstown-Warren as being from November through March. And we took a look back at the statistics. Usually during that period, Youngstown-Warren region will have between about 20 or 25 moderate AQI days during that entire period. So considering these factors, I'd like to ask you guys to make a prediction. I'm setting the over-under for this little betting exercise at 20.5 moderate days during the next PM season. And I want to hear what you guys think about that and what your bet would be with that over-under at 20.5.
You have my attention at food, by the way, Vegas Johnny. I guess I'll go first. 20.5 is the over-under we're setting it at. I'm going to go with the over. I think we're going to have at least 21 moderate AQI days in the Mahoning Valley for the winter forecasting season between November 1, 2022 and March 31st, 2023. Steve?
Yeah, I'm gonna take the under. Just kind of how this pattern's lining up. I think we're gonna have a lot of active weather systems, or at least fronts moving through, helping with dispersion this winter. So I will go with the under.
I'm going to place a bet, even though I'm the house in this case. I think the stronger anomaly signature was in the precipitation. So I'm with Steve on this one. I think we're going to get more storm systems. So I'm going to take the under. I think it's going to be 20 or fewer moderate days this upcoming winter.
And my rationale for taking the over is twofold. First off, last winter, 2021, 2022, there were only 14 moderate AQI days in the Mahoning Valley between November and March. And the season prior to that, winter 2020, 2021, there was roughly around 25 moderate AQI days. So I think we're due to get back into the 20s for moderate AQI days here for winter 2022, 2023. And I'm very interested to see if we do end up getting above average precipitation in the form of rain and or snow, and how that may impact air quality levels in the sense of fog and high humidity. So that's my rationale for taking the over. At least 21 moderate AQI days. That's what I'm predicting this year. By the way, important to point out here that we have had 8 consecutive winter forecasting seasons where the AQI levels in the Youngstown-Warren region failed to reach the unhealthy for sensitive groups category. Well, fingers crossed at least that it'll be the 9th consecutive winter season where we don't see a federal exceedance for PM 2.5.
That is great news. Thanks, Jeff, for sharing that. Yeah, and hopefully we're trending cleaner overall.
Well, that wraps it up for the Winter PM 2.5 podcast for the Mahoning Valley. For air quality information 24/7 in the Youngstown-Warren region, visit mahoningvalleyair.org. The High Pressure Podcast invites you to follow us on Twitter. We're at High Pressure Pod. And to see some of the amazing air quality work that we do here at Sonoma Technology, go ahead and visit our website, www.sonomatech.com. I'm Jeff Beamish.
And I'm Patrick Zahn.
And I'm Steve Irwin.
Thanks for listening to and watching the High Pressure Podcast.